So, right here, exponential functions have the form f of x equals abx, where a is the coefficient, b is the base, x is the exponent, okay? Exponential functions, x in the exponent, right? Exponential, x in the exponent. Sounds the same, right? In our exponential functions, our domain is going to be all real numbers, so from negative infinity to infinity, okay? And our range is going to be all y values that are greater than or less than the asymptote that we'll have on each exponential function. So, and we'll go over how you get that asymptote, okay? This first example here on the left is an example of exponential growth. All right, we read graphs from left to right. It is increasing from left to right, exponential growth, okay? We will have exponential growth when b is greater than 1, okay? When b is greater than 1. This example right here is the function of 2 to the x power, okay? So that 2 is greater than 1, right? It can be anything at 1.1 and up, okay? We'll say if it's 1 to the x power, it's just a horizontal line, okay? 1 to the x power is just a horizontal line, okay? Our example here is exponential decay. It is decreasing, okay? It is decreasing. Reading it from left to right, it is decreasing, exponential decay. We'll have exponential decay when b is in between 0 and 1, okay? It's going to be a fraction or a decimal in between 0 and 1, okay? If it's greater than 1, it is going to be exponential growth. If it's less than 0, it's going to be a reflection, okay? All right. This example right here, and is an example, is y equals 1/2 x, giving us that decrease, okay? So, both of these exponential functions are going to have an asymptote. Both of them are at y equals 0 here, okay? Both of them are at y equals 0. That y equals 0 comes from our function. There's no number to the right, okay? There's no transformation up or down, okay? Very similar to the cube root functions, square root functions. There's no number out to the right here, so that asymptote is at y equals 0. Same here. There's no number here, right? Similar to our quadratic functions, all those functions we've been doing, there's no number out here, so that asymptote is going to be at y equals 0, okay? What is an asymptote? Anyone know? It's an imaginary line that our function approaches but never touches, okay? It approaches it but never touches it. If I graphed this and I zoomed out or zoomed in, I could go all the way to like 1,000 on the x's, and this function would still not have touched 0 on the x-axis, okay? Just keeps going forever and ever, okay? All of our exponential functions will have anchor points, okay? Call it the anchor point, okay? You get that anchor point from A, okay? You get that anchor point from A. Also, just by plugging into x, you get it, but you know what that anchor point is from A, okay? So for example here, A is an understood 1. 2 is B, it's the base. There's nothing there for A, right? It's a 1, okay? So that anchor point is at 0, 1. There's no transformation. Same here. There's an understood 1 right there, okay? So our anchor point is at 0, 1 there, okay? So right here I have it drawn, or horizontal asymptotes, and then it's y equals 0, and we get it from there, okay? then our anchor point comes from these ones right there. Okay? Does everyone have this written down? Does everyone have this written down? Okay. So if you look at our parent function right here, the function of 2 to the x power. First, I'm going to do 2 to the negative first power. What do we do when the exponent is negative? We do what?
Flip it.
Flip the base. Good. So 2 to the negative first will be 1/2. So when x is -1, the y is 1/2. Okay. So next, we'll have our anchor point, 2 to the 0 power. Anything to the 0 power is what? 1. 0, 1. Again, that is our anchor point, right? There's an understood 1 right there. You know it's going to be 0, 1. Okay? All right, I plug in 1 into my exponent. 2 to the first power is 2. So that next point is at 1, 2. 2 squared is 4. So I have a point at 2, 4. 2 cubed is 8. Point at 3, 8. Now you don't need to do that many points every time. Okay? That just fit in nicely here, so I did that many points, okay? I want you to see the table. I want you to see the add, multiply rule, okay? In our table, you notice the x values, as they increase by 1, what's happening to the y values? Multiplying by 2, right? 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. And what is b in that problem? 2. Okay? It's increasing by, you're multiplying by 2 each time. As you increase by 1, you're multiplying by 2 to get those points, okay? All right. Our asymptote here, right? There's no transformation, so it's at y equals 0. All right, I put a dashed line there. Dashed line there. Next, for our y-intercept or our anchor point, I already talked about that. It's at 0, 1. Our domain is all real numbers. And then our range is all the y values greater than 0. Okay? Our horizontal asymptote is at y equals 0. So it's all y values greater than 0 there. Okay? Any questions so far? Okay. All right, what's the difference in the next example? Isabella.
It's even more stretched out.
It is because the base is what? 4. So as we increase, we will be multiplying by 4 each time, right? So our anchor point, again, it doesn't change. It's still 0, 1 because there's no number in front of that base, okay? So that anchor point is still 0, 1. Okay. That first point, 4 to the negative first power. Don't worry about doing the negative. 4 to the negative first power. Again, like Isabella said, what do we do when our exponent's negative? We flip, right? So that makes it 1/4. Then my anchor point, 4 to the 0 power. Anything to the 0 power is 1. So I have 0, 1. That next point, 4 to the first power is 4. 4 to the second power is 16. 4 to the third, 64, right? As we increase by 1, we're multiplying by 4. That base is 4, right? Okay. So a little way to think about it quicker and work it a little faster, right? Obviously, you're not going to put 364 on that graph, okay? What would that asymptote be there, that horizontal asymptote? Y equals 0. And what would that anchor point be? 0, 1, beautiful. All right, make sure you're putting that dashed line in there for the asymptote. Domain, what would that domain be? All real numbers, every x value, right? It's covering every x value. All right, and then what would our range be? Right, all y values greater than 0. 0 to infinity. Good. All right. Both of these are examples of decay or growth? Growth. Good. Exponential growth. They are increasing. We read from left to right. Okay? This third example here. All right, now we have an A. Okay? That A is going to change the anchor point. Okay? It's going to change the anchor point. Also be a vertical stretch. Okay? So the way we set up this box, first we'll do PIMDOS, the exponent, right? 2 to the x power, and then we'll multiply it by 3, and we'll get the y, okay? So, started with -1 again. 2 to the negative first power is 1/2. And then 1/2 times 3 is 3/2. Or 1.5. Okay. All right, 0. What's 2 to the 0 power? 1. And then what's 1 times 3? 3. Our next point is 2, 3. I'm sorry, 0, 3. Okay, our anchor point. What was A? 3. A was 3. What's our anchor point? Huh? 0, 3. Good, Jasmine. Good. All right, so, all right, that's showing that new anchor point. It's going to be vertical stretch there. Okay. Now, 1. What's 2 to the first power? 2 to the first power is 2. Times 3 is 6. Good. 2, 6. Then we'll have 2 squared is 4 times 3 is 12. Okay. So again, as you can see, right? What is B? 2. Each time our y is doubling. Each time our y is doubling. Good, 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 good. Good, good, good. All right. Obviously, it's up here. What's my asymptote? Y equals 0. There's no transformation up or down. We're going to do that next. Okay? Anchor point 0, 3, y-intercept. Domain is all real numbers, and again, our range is the same. All y values greater than 0. Okay? Raise your hand if you got this down. Okay. I meant like actually writing it down. Raise your hand if you're not done writing it down. Okay. All right. Transformations, translations, transformations. Okay? So, the equation f of x, a, b, x minus h plus k is the translation function. Helps us understand how changing values impacts the resulting graph. The h is going to tell us about horizontal movement. If h is positive, we're moving to the right. right? Remember, it's minus h, so that h is 2, right 2. H is negative, will be to the left, minus a negative 2. So remember, that will look like x plus 2. Okay. A tells us about stretching, reflecting, and compressing. Okay. If A is less than 0, it is reflecting over the x-axis. Yeah. Example there, y equals negative 2 times 3 to the x, or 2 to the x, what did I put there? 3 to the x. Vertical stretch, that number is greater than 1. Compression, that number is in between 0 and 1. I did 1/2 there, okay? It's going to be a compression, all right? It's going to compress. Then, K gives us our vertical movement. It gives us our horizontal asymptote. K is positive, it's moving it up. If K is negative, it is moving it down, okay? All right, so looking at this first example here, what kind of transformation is this going to be? Right, how many? Right 2. All right, don't worry about plotting the points. I'm sorry, don't worry about making a table. Just take the parent function and move each point right 2. Okay? Move each point right 2. Okay? So, would our domain change here? No. Would our range change here? Would our range change? No. Would our horizontal asymptote change? No. All the same. Yeah. All right. There's a plus 0 there, right? None of that is changing. None of that is changing. Okay. All right, second example here. What transformation is this? Down 2. Down 2. So again, don't worry about making a table. Just move them all down 2. Does our domain change? Does our domain change? No. Does our range change? Yes, it does. What is our range now? Yes. Good. All y values greater than negative 2. Good. Negative 2 to infinity. Negative 2 to infinity. Okay. What would our horizontal asymptote be here now? Y equals negative 2. Good. Y equals negative 2. Okay. Third example here. What would this transformation be? Isabella. Reflection. A is negative. Reflection over the x-axis. Okay, so you were literally reflect that. Can't do the third when x is 3. Okay, so negative 1. So the easiest way to do it when you're reflecting like this, so this point's half away from the x-axis, go down half. 1 away, down 1. 2 away, down 2. 4 away, down 4 there. Okay. That shows us our reflection. Okay. Does our domain change here? No. It's still every x value. Does our range change? Yeah. Okay, what is our range from? Right, it's all y values less than 0. In interval notation, you'd write that from negative infinity to 0. Okay. What would the horizontal asymptote be here? 0. Good. Y equals 0. Y equals 0. Good, good. All right. What would be the transformation here? Left 2. Good. Left 2. All right. That domain and range will stay the same. Just take it from the parent. Just move each point left 2. All right. Example here, 2x plus 3. What would the transformation be? Up 3. All right, so what would our horizontal asymptote be now? Huh? 3. Y equals 3. Y equals 3. And now our range is all y values greater than 3. The 3 to infinity. Okay? 3 to infinity. All right, 2 transformations on this example. What is A? Right? A is what? Because it is negative, so it's a reflection over the x-axis. Is it greater than 1? So what's it going to do? Stretch, right? So reflection, and it's going to stretch. Okay. So here, I went ahead and did the points. This is harder to do. You can't. This is harder to do to copy it. So I plugged in -1. You got -2 times 2 to the negative first. Right? 2 to the negative first is 1/2. -2 times 1/2 is -1. So I plotted that point. Okay. Then I did 0, -2. I think I did. Okay. You got negative. All right. So then we knew our anchor point from the start is at 0, -2, because A is -2, right? That always gives us, A always gives us our anchor point. 0, -2 there. So technically you don't need to plug that 0 in. And then I plugged in 1, I think. Yeah. So 2 to the first is 2 times -2 gives you -4 there. Okay? Gives you -4 there. 1, -4. So reflection, and it's going to be stretched, okay, towards that y-axis, right? It's going to get tighter. So domain is still all real numbers. That range now, y value is less than 0. -infinity to 0. Asymptote is y equals 0. Okay. Questions there? Any questions there? Okay. Let's get into this a little bit. All right, number 1 on the homework sheet I passed out. Would that be, or what would be, on 1, what would be the horizontal asymptote? Huh? 3. Give me the exact answer. Y equals 3. Good. All right. And then would this be growth or decay? Growth. Good. 2. What would that horizontal asymptote be?
0.
Thank you. All right, y equals 0. Would that be growth or decay?
Okay.
What is B?
5.
5/8. Is 5/8 in between 0 and 1? Yes, so it'd be decay. Good. All right, 3. What would be the horizontal asymptote? There you go. Y equals -5. Good. That'd be growth or decay? Growth. Okay. Good. Good. The last part, this matching part, okay? Let's work through this real quick. All right. Actually. All right, number 10. What's a huge clue on 10? The asymptote being down 2 is huge. And decay. So that would be what? A. Beautiful. All right. Number 11. What's a big clue there? The what? On 11. Not 10. Not 12. Huh? What's a big clue on 11? What about A? What's A?
It's a reflection.
Nope. 11. 4 times 2 to the x. What is A? Nope, that's not what I'm asking. What number is it?
4.
It's a 4. What is A also? The anchor point. The anchor point. What is the only graph on here with an anchor point of 4? D. All right, 12. Okay, give me the clues on 12. It's decay and it's left 1, right? It's decay and it's left 1. So, what would that be? Be F. Good. Right, it's left 1 and it's a decay. Okay, it's left 1 and it's a decay. 13. Big clues on 13. It's a decay and it's up 2, right? It's a decay and up 2. Yep, so we see that horizontal asymptote at y equals 2. It is C. Very good. All right, 14. Big clues there. Right, horizontal asymptote at y equals 1, and it is what? Right 2. So what would that be? E. Good. Now, obviously, 15, there's 1 left. But again, the big clue here, what's that asymptote at? -1. Got B there. Okay. Any questions there? Right, those clues are key, right, Bradley? All right, so big clue from the start, our horizontal asymptote is at y equals 4. So I'm going to draw that in. 1, 2, 3, 4. Okay. Our anchor point would have been at 0, 3. 1, 2, 3, but it's up 4 from there. Okay. 1, 2, 3, 4. Okay, so I know my anchor point's going to be at 0, 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6, 7. Now, if we plug that in, obviously you could do that, work in the table, and you would get 7 there, okay? It's going to be a vertical stretch, and it's going to increase by 4 each time. So, like, if you plugged in 1, I know that because B is 4, right? So that Y value is going to increase by 4 each time. If I plugged in 1, 3 times 4 to the first power plus 4, that's 12 plus 4, which that would be 16, which isn't an increase by 4. So that'd be 116. Right, big stretch there. Also put in -1. Actually, real quick, I'm putting the domain will be all real numbers. And that range would be from 4 to infinity there. Okay. And then real quick, I'll try and get before the bell rings. 4 to the -1st plus 4. That's 3/4 plus 4. So 4 3/4. Right in there. We would have our function right there. Okay. I'll post this on